The ability to traverse great distances swiftly and efficiently has been a hallmark of progress, and no mode of transportation epitomizes this more than air travel. Since the Wright brothers' pioneering flights in 1903, the aviation industry has evolved into a global force, playing a pivotal role in shaping the modern interconnected world we live in today. The importance of commercial flight extends far beyond its role as a mode of transportation. It serves as a catalyst for economic growth and cultural exchange. While technological advancements have allowed planes to soar through the skies with remarkable precision, the weather still remains an adversary that pilots must contend with on a daily basis. Each season presents its own set of challenges. Winter, in particular, introduces a range of atmospheric phenomena that significantly affects aircraft operations. Winter weather often brings icy runways and snow-covered surfaces, posing challenges to pilots. Ice is also a significant threat to aircraft as it may accumulate on critical surfaces, impeding their performance and jeopardizing the safety of the flight.
One of the things you have to be very careful with on airplane wings is ice because it deforms the airflow over the wing. Very dangerous. Also, ice adds weight to the airplane. There's all kinds of problems.
To resolve these issues, planes have certain procedures that ensure the safety of the flight. Typically conducted prior to takeoff, de-icing involves the application of specialized fluids to melt existing ice or prevent its formation. These de-icing fluids are heated and often contain chemicals that effectively remove the ice buildup. After de-icing, it is crucial for a plane to depart as quickly as possible, as further delays may limit the effectiveness of the treatment.
That's so important that you have de-icing that's very quick so you can get off because it's all different. Some ice is very negligible. Sometimes the snow hits hard, 2, 3 inches an hour, and you just can't de-ice it to get. You can't make it.
Freezing rain presents an even greater challenge as it coats surfaces with layers of ice.
Freezing rain is really tough. That's worse than snow in any respect because it's very hard to see it and it adheres quickly and it's heavy.
When the weather becomes warmer, wind becomes the main challenge for pilots and airlines alike. Takeoff and landings are especially dependent on winds, as the winds such as tailwinds may threaten the safety of the flight.
A tailwind is really tough because the airplane flies with airspeed, not ground speed. So the airspeed is going to be the same for takeoff no matter what, but the ground speed will make the takeoff longer if it's a tailwind. That's why it's always great to take off into the wind because you can take off in less distance.
Another type of wind that pilots tend to avoid is crosswind, which is the horizontal wind blowing perpendicular to the aircraft's intended path.
Crosswind is always tricky. You have a lack of a headwind, and then the airplane's being pushed sideways. Let's say the wind is from the right, the airplane's being pushed over toward the left. So you have to keep the wing down. So you don't want that wing to pop up. That's what will happen because it's getting more lift on one side than the other.
An important wind related hazard is the presence of wind shear. Wind shear is characterized by the sudden change in wind speed or direction over various altitudes and locations. Encountering wind shear during takeoff or landing can be hazardous. Low-level wind shear associated with downdrafts and updrafts within thunderstorms can induce rapid and unexpected changes in aircraft performance.
But wind shear is particularly dangerous. You can't see it normally. That's the problem. Initially, if you're heading into a downburst, you get a headwind and the airplane performs better. And then all of a sudden you get pushed down. And as you exit that area, you get a tremendous tailwind, which that's where it's so dangerous.
Not only is the shear associated with a thunderstorm the only dangerous aspect of flying, the turbulence associated may threaten the safety of the passengers. While thunderstorms are a well-known source of turbulence, there are various other forms of turbulence that pilots and passengers may encounter.
Turbulence is always interesting, especially clear air turbulence, where you don't see anything. You don't see, like a thunderstorm, you see it, or when you get into cumulus clouds, you get bounced around a little bit. But clear air turbulence is very tricky. Uh, Sometimes you can detect it. The other thing is the jet stream produces turbulence, and it tends to be wound up tighter in the northern hemisphere on the north side. And you get a little bumpiness once in a while. Sometimes it's smooth, sometimes it's bumpy.
Terrain and mountain ranges can also produce their own form of turbulence.
Anywhere where there's a good stream of air moving fast, you're going to get turbulence when you get near the mountain. There is a thing called a standing lenticular, very dangerous because It's actually being a mountain wave pushed over the top of the mountain. Looks like it's not moving. It looks like beautiful, very nice, very dangerous. Stay away from those.
The impact of weather on flying is a multifaceted and crucial aspect of aviation. From turbulence and thunderstorms to strong winds, the diverse array of atmospheric phenomenon poses continuous challenges to the aviation industry as a whole. Pilots play a pivotal role in ensuring the safety and success of flights, as they must interpret complex meteorological data and skillfully maneuver through adverse conditions. However, as long as we rely on Earth's atmosphere for flight, weather will continue to exert its influence on the world of aviation. For Weatherworld, I'm David Guerrero.